Yeah, good morning to all of you. In the previous video, we have discussed the fundamentals of Coulomb's law, which states that the force between 2 point charges is directly proportional to the product of charges and inversely proportional to the square of distance. And we have already discussed the validity of Coulomb's law and application. So in this video or in this lecture, I will discuss the few examples to understand the concept of Coulomb's law mathematically. So the first example is that given that 2 point charges, we have 2 point charges, given that 2 point charges, 2 point charges Q1 is 25 nanocoulomb, NC, and Q2 is minus 75 nanocoulomb, are separated by a distance R which is equal to 3 centimeter, as indicated in figure, as shown in figure. This is R, this is Q1, this is Q2. So find the magnitude and direction of force. Find magnitude and direction of force. So solution. So how to find out the force between these 2 point charges which is separated by a distance law? So we have very good tool, that is Coulomb's law. So using Coulomb's law, we can find out the force between these two charges. These two charges are point charges which are separated by distance r equal to 3 centimeter. So using Coulomb's law, which states that, which is 1 upon 4 pi epsilon 0 q1 q2 by r square. The value of this constant is 9 into 10 to the power 9, and q1 is, we have q1 is 25 nanocoulomb. So let me write q1 in terms of coulomb. So q1 is what we have given, that from this example we have given that q1 is 25 nanocoulomb, which is 25 into nano means 1 nanocoulomb is equal to 10 to the power minus 9 coulomb. So this is 9 coulomb. And similarly q2 is minus 75 nanocoulomb, which is minus 75 into 10 to the power minus 9 coulomb. So n means nanocoulomb. So using, and r is, what is r? R is 3 centimeter. See, mind it, in this expression each and everything is, the unit of this f is Newton. So f is Newton, which is MKS unit. So mind it, each and every parameter is in MKS unit, but in example our r is in 3 centimeter, which is 3 centimeter. So centimeter is CGS unit. So anyhow we have to convert, and we have to take care of our unit system. So each and every parameter is in same unit system, whether it is in MKS or in CGS. So here q1 q2 in coulomb, so r is in CGS, so we can convert in point. R is 3 centimeter, so which is, so we know 1 centimeter is 10 to the power minus 2 meter, or 1 meter is 10 to the power 2. This is basic. parameter. So 3 centimeter is 0.03 meter. Now each and everything is in MK, and the value of this constant is also in MKS system. The value of this constant is also in MKS system. So now 1 upon 4 pi epsilon 0 is 9 into 10 to the power 9, 9 into 10 to the power 9, and the unit of this we can find out the unit Newton meter square per Coulomb square, Newton meter square per Coulomb square. So each and every now in this each and every parameter is in MKS system. So now putting the value of each constants and variable, which is we have the value of this 1 by 4 pi epsilon 9 into 10 to the power, and q1 is 25 into 10 to the power minus 9, and this one is minus 75 into 10 to the power minus 9 divided by r square, means 0.03 square. So what we have, so 9 into 25 into minus 75 into 10 to the power, this 9 will cancel out, and we have only this 9, and this becomes 3 into 10 to the power minus 4, sorry not 3, this is 9 square of distance. So 9 into 10 to the power minus 4. Now after calculating or rearranging, this 9 will cancel out, and this will goes here. So after calculating what we have simply 1875. So this will cancel out, and multiplying this 1875 into 10 to the power minus 5, this is minus 4, and this is minus 9, this goes up, and we have 95 plus 4. So this is what we have, 187, and minus sign is also there. There is separate meaning of this sign. So this much amount of this much Newton, which is 1875 into 10 to the power minus 5 Newton, this much force. And what is the role of this sign? This sign shows that here q1 is positive and q2 is negative. So we can say that the nature of charge is attractive, because q1, if q1 q2 is in opposite sign, so the nature of force is attractive. If this q1, in previous lecture what we have discussed, that the q1 q2, the sign of q1 q2 decides the nature of force. If the sign of q1 q2, if the q1 q2 are of same sign, so the force is repulsive. If it is in opposite sign, one is the force, in that case the force is attractive. So in this case the q1 q2, q1 is positive and q2 is negative, therefore the force is attractive. The nature of force attractive. So Coulomb's law, with the help of Coulomb's law, we can find out the nature of force and magnitude of force also, and this is the importance of Coulomb's law. So it's all about this example. In this example we have information about q1 q2 and distance. So with the help of this q1 q2 and distance, we can find out the force, magnitude of force, and nature of force, whether the force is attractive or repulsive. Thank you. Next example. So we have another example. Let me tell you the another example. An alpha particle has mass. An alpha particle has mass has mass 6.64 into 10 to the power minus 27 kg, and charge is twice of E, where E is the charge on electron, which is 1.6 into 10 to the power minus 19. So find the magnitude of electric repulsion. So find the magnitude of electric repulsion, because the charges is twice of E. So that's why the nature of force is repulsive. So we have to find out the nature of force, magnitude and nature of force. So nature of force is repulsive and magnitude. So with the help of Coulomb's law or using Coulomb's law, we can find out the force. We have another set examples. So this is just a home assignment. So we can find, we have another example, the repulsive force between two equal positive charges. The repulsive force between two equal positive charges, positive charged ion is 3.7 into 10 to the power minus 9 Newton when placed at a distance 5 angstrom. Calculate number of electron missing from each ion. Calculate electron missing, calculate number of electron missing from each ion. So this is another very important example which tells us that with the help of Coulomb's law we can find out the charge, distance, force and number of electron also. So number of electron, how to calculate the number of electron? With the help of, we have a formula. So number of electron are total charge Q is equal to N into E. This N is the number of electron and this E is the electronic charge, and we know the value of this E. The value of E is basically 1.6 into 10 to the power minus 19 Coulomb. So if we have idea about, so with the help of Coulomb's law we can find out the charge, and once we know the charge we can easily find out the number of electrons. So number of missing electron is equal to charge by E. So in this example is entirely different from the previous example. So let us understand the concept. What we have the information about the force. In the previous case we have information about charge and separation distance, but in this case we have information about the force and distance, and we have to calculate Q, and once we know the Q then divide by E in order to find out the number of missing electrons. So let us see. So using Coulomb's law, which tells us F equal to 1 upon 4 pi epsilon 0 Q1 Q2 by R square, which implies that Q1 Q2 by R square. So we don't have idea about, in this case Q1 and Q2 is Q. Q1 and Q2 is Q, which is twice of E, So what is, so given that F is given and Q1 Q2 is equal to Q, which is twice of E, So with the help of this we have, which is twice of E. So twice of Q1 Q2. Now putting the value of Q1 Q2 Q, twice of E, R square, and R is 5 angstrom, which is 5 into, in MKS system, 10 to the power minus 10 meter. Now putting all the value, and we know the value, this 1 upon 4 pi epsilon is simply 9 into 10 to the power 9 Newton meter square per Coulomb square. So putting all these value, putting the value of all these parameter in this expression, and what we have Q is simply, so what is our Q here? Q square is FR square by 4 pi 1 upon 4 pi epsilon 0, So basically Q square is FR square divided by 1 by 4 pi epsilon 0. So now putting all the parameters, we have Q is basically 10.28 into 10 to the power minus 38 Coulomb. So and Q is, this is square, Q is basically 3.2 into 10 to the power minus 19. So once we have a Q, we can easily find out E. So just do it and you will get the number of missing electrons is roughly of the order of 2. So this is the way to apply the Coulomb's law and to solve the different types of situations. In some situation we have given value of Q1, Q2 and separation distance. In some situation we have given the magnitude of force and charge and distance. With the help of these we can find out the charge. Once we know the charge, we can find out the missing electrons. So this is number of missing ions, not electrons. In this case this is ions, is 2. Thank you.